Hey everybody, welcome back. We're going to be doing section 3.5 today. It's division of polynomials. This is a how-to section, how to do things. The next section will be how come, why are we doing this? At least a little bit about that, and then you'll see this again in calculus. But this section will be very, very good for you in terms of honing your algebra skills and your arithmetic skills. So this is a how-to section. And the best way to learn it is to do examples over and over again. But so this is called division of polynomials. So I just consider 172 divided by 3. And what we do for that? Well, let's see. We know this is the standard algorithm. It's called the standard division algorithm. 172, 3 into 17. You say, oh, how many times? What do I have to multiply that by to get near there? Well, 5 will do. And then so 50. And then what do we do here? We subtract. 7 minus 5 is 2, and 22 is left. 3 into 22. Well, let me see. What do I have to multiply? Oh, how about 7? 21. Multiply 3 times 7 to get 21. And then subtract. This would be a remainder of 1 or 1/3. 3 times 57 and 1/3 is 172. Now consider another one just because that has no that has a remainder of 0. 3 into 285. And we just want to think about what we're doing here. That's a 9, right? 27, subtract 1, 5, 95. 0, remainder of 0. 3 and 95 are factors of 285. So that's where we're headed. That's what's behind what we're going to do. Now consider 3x squared plus 4x minus 7. Consider this, 3x squared plus 4x minus 7, and we want to divide it by x, I think, minus 1. Yes. So we want to divide, this is dividing polynomials. And so suppose we do the exact same thing we did in this board. X minus 1 into 3x squared plus 4x minus 7. All right, what do you do over here? The same thing. Well, we need to multiply that x by something to get 3x squared. X times what is 3x squared? Do you understand that? X times 3x is 3x squared. So now I'm multiplying these two. That's what I want, because I want to subtract and get 0, and I have to multiply these two. Minus 3x. Keep in mind, I'm subtracting here. So this is, and these will go. Because you picked the right quotient. This is 4x minus negative or plus 3x, which is 7x minus 7x into 7x. What do I need to multiply that by? How about 7? X times 7 is 7x. X times minus 1 is minus 7. I'm subtracting these two. I get 0. X minus 1 and 3x plus 7 are factors. And you can check that out. I mean, just multiply it out. Just FOIL it. This is what you get. I made it up. I know that. So that's what polynomial division looks like. We're doing the same thing we did over here, only we're going to take a shortcut. It's called synthetic division soon. Let's do one more of those. Make it a little more complicated, I guess, and then we'll hit synthetic division. Please learn it for your own good. Next semester, next section, it'll come into play, and then finally in Calc 2, in chapter last time we talked, it was chapter 7. Synthetic division was all over the place. But anyway, suppose we want to one more polynomial. Suppose we want to take x plus 2 and divide it into, if you would, 2x 2 minus 3 4 5. 2x cubed minus 3x squared plus 4x plus 5. And we're going to multiply. We're going to divide. So x, how many times, what do I have to multiply by? Whoa, how about 2x squared? Do you understand that? That's important. This times this. That's why we chose it. Then you take 2x squared times 2 plus 4x squared. And now we're subtracting all this. So that's minus 3x minus 4x minus 7x. I subtracted. squared, sorry. And then I'm bringing down to 4x plus 4x, just like we did in the standard division problem. X into minus 7x, minus 7x squared. This is minus 7x squared. That's why we chose that. And we're going to be subtracting 7x. Minus 7 is minus 14x. And we're subtracting that. The whole thing. We're subtracting that. So that goes, and this is 18x. X into 18x plus 18. 18, I forgot to bring down 5. 18x plus 10. Is that right? 36, I'm sorry. Plus 36. And I'm subtracting. Minus 31 is the remainder. Negative 31. There's a theorem coming. Negative 2, negative 31 is a point on the graph. That's called the remainder theorem. That's coming next section. But so what we would write is x plus 2 times, let's see, 2x squared minus 7x plus 18 plus a remainder, which is minus 31 over x plus 2. Just like the standard division algorithm. Now let's try to cut some time off there, because there's a much quicker way to do it. It's called synthetic division. There's no reason to write all those x's. Here. So I'm going to do that exact same problem. Notice, if x plus 2 is a factor, then x equals negative 2. So that's one thing about synthetic division. This is synthetic. Please get good at this for your own benefit. Synthetic division. And this is of polynomials. That's what we're doing. We're dividing polynomials. And so this section, this is all we're going to be doing, synthetic division, for the rest of this tape. We're dividing polynomials. And so note here, what I want to do is I want to take negative 2, because x plus 2 is what I want. And divide it into 2 minus 3, 4, 5. There's no reason to write the x's, is my point. Synthetic division, this is how. This is bring down, multiply, add, bring down, multiply, add, bring down, multiply, add. That's what you're going to be saying to yourself all over again. This is a procedure. We do a little box like that. Bring down, multiply, add. This is what you say. Bring down. Going right there. Multiply. Add. Add because it's negative 2, by the way. Okay, so I'm bringing down 2. All I did is bring that down. Multiply. Negative 4. I'll put that right here. And then add these 2. Multiply. And then add those 2. 14. I'm sorry about that. I'm going too fast. Multiply. Add those 2. Multiply. Negative 36. Add. Negative 31. Same result we just got, only it's called synthetic division. Bring down, multiply, add. Bring down, multiply, add. Let's do another. The rest of this section, the rest of this tape is just examples of synthetic division. If you know what you're doing, turn it off. 1, 3, 4, negative 7. How about take x minus 1 into 3, 4 minus 7. 3x squared minus 4x plus 4x minus 7. And I know this, I factored this. I know x minus 1 is going to be a factor because I did it. But here we go, by using synthetic division, if x minus 1 is a factor, then x equals 1. That's the divisor. Then we don't have to write the x's. Bring down. Multiply, add. Bring down. Multiply. Add. Bring down. Multiply. Add. What this shows is x minus 1 times 3x plus 7 is plus 4x minus 7. This is a factor. Then that's a factor. We're going to, next section, you're going to have something called the factor theorem. I made that one up just to show. Let's go a third degree. 1, 1, minus 10, 8. 1, 1, minus 10, 8. Boy, as you do this, you're going to understand what I'm writing down there. Bring down, multiply, add, and what we want to divide that by is x minus 2. So we're putting a 2 here. This is the problem. X cubed plus x squared minus 10x plus 8 divided by x minus 2. That's how you set it up synthetically. This is so much quicker. Bring down, multiply, add, multiply, add, multiply, add, boom. Hey, so x minus 2 times x squared plus 3x minus 4 is this polynomial. Hey, we want to get everything in factored form. X, what is this? Plus 4, x minus 1. There you go. It's all in factored form. That's what the whole goal is, using synthetic division. Now, there's some things, I didn't talk too much about. If this is a third degree polynomial, then that's going to be a second degree polynomial. Let's try this. Do I have a fourth degree? Oh, what happens? Yeah, I do have a fourth degree, but suppose there's a 0. A 0 in the polynomial. That means one of these a sub i's is 0. For example, suppose I want to take x minus 3 and I want to divide it into, we're not writing this anymore, x to the 4th, 13x squared plus 36. Plus 13x squared plus 36, I think. One of these is a minus, hang on. Minus 13x squared, sorry about that. Okay. Now, so that's what I want to do, but let's set it up synthetically. If x minus 3 is a factor, that means I'm dividing by 3. Here we go. 1 minus 13, 36. This is important. If the third degree is 0, this first degree is 0. You must have those represented. Now, please understand, this is a fourth degree. So what we're going to get down here is going to be a third degree. We're just breaking it down by one factor. So here we go. 3. Bring down, multiply, add. Bring down. 1, 3 down to 3. Add. 3. 3 times 3 is 9. Add. Minus 4. Multiply. 12. Minus 12, sorry. Add. Minus 12. Multiply. Add. X minus 3 times, that's x to the third. I mean squared, rather. Excuse me, that is x to the third. Because this is fourth degree, plus 3x squared minus 4x minus 12. And our factors, because of that remainder of 0, that's coming next section. And if you set that equal 0, you'll find you can factor this. Factor x squared out of there, you'd have x plus 3. Factor 9, 4 out of there, you'd have x plus 3. So you can keep going on that. One more. Suppose the divisor is a fraction. So we want to take 2x plus, I forget, that might be minus, into, where are we? 6, 7, minus 4, 7. 6x cubed minus 4x squared plus, I think I just made this up, right? It doesn't matter, 4x plus 7. Something like that. I don't know. I think I made that up. But so we want to do that. Now, if 2x minus 1 is a factor, that means that's set equal to 0. And then x equals a half. That's the divisor in synthetic division. Bring down, well, right, 6, negative 4, 4, 7. 3, 2, 1, zippo, exponent. Bring down, multiply. Oh, that's right. This is not the same one. Add. Multiply. Add. 8 halves minus 1 half, 7 halves. Multiply. Add. 7, that would be 28 fourths, and 7 fourths is 35 fourths. That is what the remainder. If you take 2x minus 1 times 6x squared minus x plus 7 halves, you get a remainder of 35 fourths. That's it for this one. See you next time.